Hello students. Welcome to Varun Tutorials. In this video, we are going to learn about Bernoulli's differential equation. We will cover the definition of its standard form, case 1 when n equals 1, case 2 when n is not equal to 1, the integrating factor, and the general solution formula. Let us understand the theory step by step. First, let us define Bernoulli's equation. A first-order and first-degree differential equation of the form dy by dx plus p of x times y equals q of x times y to the power n. Let us call this equation 1, where p of x and q of x are constants or functions of x alone, and n is a real constant. Let us discuss the first case, when n is equal to 1. Equation 1 can be written as dy by dx plus the quantity p minus q, times y, equals 0. Let us call this equation 2. Here, the variables are separable. The general solution is obtained by integration. The integral of dy over y, plus the integral of p minus q, dx, equals 0. Now, let us discuss case 2, when n is not equal to 1. Multiplying equation 1 by y to the power of minus n, we get y to the power of minus n, times dy by dx, plus p of x times y to the power 1 minus n, equals q of x. Let us call this equation 3. To reduce this to a linear form, we use substitution. Let us put z equals y to the power 1 minus n, which gives dz by dx equals the quantity 1 minus n, times y to the power of minus n, times dy by dx. Substituting these values in equation 3, we get 1 over 1 minus n, times dz by dx, plus p of x times z, equals q of x. Multiplying by 1 minus n, we get dz by dx plus the quantity 1 minus n times p of x, times z, equals 1 minus n times q of x. Let us call this equation 4. This is a first-order linear differential equation in z. The integrating factor is calculated as follows. Integrating factor equals e raised to the power of the integral of the quantity 1 minus n times p of x, dx. Finally, let us obtain the general solution. Hence, the general solution of equation 3 is z times the integrating factor, equals the integral of the quantity 1 minus n times q of x, times the integrating factor, dx, plus c. Substituting the value of the integrating factor explicitly, we get z times e to the power of the integral of 1 minus n times p of x dx, equals the integral of 1 minus n times q of x, times e to the power of the integral of 1 minus n times p of x dx, dx, plus c. Let us call this equation 4. Substituting z equals y to the power 1 minus n back in equation 4 gives the final general solution. We obtain the general solution, y to the power 1 minus n, times e to the power of the integral of 1 minus n times p of x dx, equals the integral of 1 minus n times q of x, times e to the power of the integral of 1 minus n times p of x dx, dx, plus c. Thank you for watching. If you found this helpful, please like, share, and subscribe to Varun Tutorials. Turn on notifications so you never miss a new video.